So yes, I'm Ashwin. I'm currently a master's student at Simon Fraser University in Canada. And this year I mainly worked on adding a few features to CliMetLab, which is a package currently being developed at ECMWF, mainly by Bodoan and Florian, my mentors. And I worked with them during this 3 months, and I've tried adding a few functionalities in terms of drivers and plugins, which I'll be presenting now. Next slide, please. So firstly, to give you an overview of how the CliMetLab is managed and how it's currently being developed, the library is still in very early stages. So there are four main functionalities that we can talk about. So first is data access. We can get there are multiple climate and meteorological data sets which need to be handled properly. So CliMetLab tries to give proper data access to these data sets. Then the next factor is processing of these data sets. So we need to have proper data processing. Then the format handling, we have multiple data formats like NetCDF, GRIB, and all these formats. And to handle all these formats in one library, it is currently being employed here. Then the loading of this data, it's also inculcated here. The next factor is interoperability. CliMetLab plans to provide different, so it's being developed with the view of being helpful for machine learning projects. So in machine learning community, Jupyter Notebooks and this machine learning frameworks such as TensorFlow, Keras, PyTorch are highly used. And CliMetLab plans to provide best of both. So it acts as a bridge between when you can take the data sets for your climate and meteorological data sets and plug them, you load them, and then try to train the models with this sci-fi stack and this machine learning frameworks. So you can just import these frameworks into CliMetLab and use them with the data that you have loaded. And once you have trained this model, you need to, and you get the outputs, you need to have good interpretation of this output. So we also plan to add this output interpretation functionalities, which is different graphs and curves that we get during the training of the models. CliMetLab is mainly built with this plugin architecture, which is easy addition of data sources, data sets, and plugin styles. So that's what one of this is one part of my project was this addition of Intake plugin, which was really helpful due to having this very flexible plugin architecture. Next slide, please. Okay, so to give you an overview of this year's my work. So previously I presented the overview of CliMetLab, but now I'm presenting what I tried to do as part of adding features to CliMetLab. So I mainly worked with two things. First is the plugins part, where we focused on providing simplified data access, which we tried to do with Intake library. And the other part is adding drivers. So we currently have Magix as the go-to package in most of the ECMWF software suite for plotting purposes, since it works very well with geographical plots. But for machine learning specific plotting, we tried to go with Matplotlib. So this was mainly the two tasks that I tried to work on this video. Next slide, please. Okay, so the project goals. First one, Intake is to give you an insight of what exactly I'm talking about the Intake library is. Intake is mainly a lightweight set of tools which helps in loading and sharing data primarily in data science projects. We wanted to extend CliMetLab so that it seamlessly interfaces with Intake, and it allows users for all the Intake compatible data sets. And the second goal was to extend CliMetLab so that we can offer user with high-level Matplotlib-based plotting functions. This can be helpful, as I mentioned, to produce the graphs and the plots that we get when we are training machine learning models. And this could be specific to the applications that we're planning, is specific to the weather and climate data sets. The curves and plots can be plume plots, ROC curves, training and loss curves, these and many more. So next slide. Okay, moving on to implementation details. So for the first task, when we are dealing with Intake plugin, so the Intake mainly provides, it has this advantage that datasets can be described in catalog files. When we are dealing with weather and climate datasets, we have most of the data in terms of which can be described in catalog files, and that's why it's really important. We are able to load that data with as user friendly as possible, and that's why we went with Intake. And currently the package is released on PyPy, and it's as simple as importing any other package in Python. So currently what can be done is you import CliMetLab and then you load data. And instead of you having to like write this intake things, the plugin takes care of that, and it calls the intake open dataset call. So it also handles the data dependent things. And we are currently supporting the following file formats, which are CSV, netcdf, SAR, GRIB, and Pickle. These are mainly keeping in mind that we are going for machine learning based projects. So these are the primary file formats that we come across, and that's why we are focused on this. Next slide, please. Here you can see I've released this first version of CliMetLab Intake plugin, and this is currently ready to use, and it's a better functionality for data loading. Next slide, please. Moving on to task 2. As I mentioned, Magix is currently the go-to package for most of the ECMWF like projects, and it's really a mature package. I mean, it provides various functionalities and various functions, such as you can directly select, instead of having to select latitude and longitude, you can just mention something like Eastern Europe or Central Europe, and it provides you with all these latitude longitude plots. And it's very much more mature than what we can expect with Matplotlib to plot this geographical plots. But when it comes to machine learning, it's better handled with Matplotlib. As I mentioned, this ROC curves, plume plots. Magix was not initially developed with like this machine learning functionality in mind. So that's why adding these functionalities in Magix can be one task. But at the same time, since Matplotlib is much more mature when we're going for machine learning things, it's better to see if we can just use Matplotlib with CliMetLab. So in the short term, we mainly wanted to go for integration of Matplotlib into CliMetLab and provide users with the functionality of using this graphs, which can be from Jupyter notebooks. And in the long term, we plan to have something like both the plots can be plotted with either Magix or Matplotlib. So this would be much helpful so that user can see if they are getting better performance, like better plots and with better functionality with either with Magix or with Matplotlib. So that's what we are trying to do here. We are adding both the drivers and trying to provide user with the option to select either of them. So that's a long-term goal. Since CliMetLab is in very much early development, we are currently just trying to see if Matplotlib can help with the machine learning plotting functionality. So next slide, please. So this is the current setup in CliMetLab. So we have this plotting functionality which calls the drivers API, and which initially called this Magix API, and then we had this actions and plot figure classes. But with the new addition of Matplotlib, we have both. We have Magix as well as Matplotlib, which can help, like the user can select the driver. This is currently from the view of developer, and for user, it's you can just select either of the drivers. But currently, the Matplotlib driver code is not merged with the CliMetLab. As I mentioned, it's very much in early development. But once we have merged that, we'll be able to do this. We'll be able to have both, I mean, the users. Currently, this is the developer view, but from the user point of view, user will be having both the options to use either Magix or Matplotlib. And then the user can plot the training curve with Matplotlib and at the same time get the geographical plot with Magix. So that's the plan with this idea. Next slide, please. Yes. So here I'm adding mainly the few plots that I tried to recreate, which were, so if you look at the Magix homepage, you can see many examples, which are of these geographical plots, which are very well plotted with Magix. But what we tried here is to see if we can get similar plots with Matplotlib. So apart from providing something like machine learning training curves and all, we tried to see if we can get the geographical plots as well. So that's here I'll be presenting a few plots from that. So this is the basic plot, which is a hello world plot as it's presented in Magix tutorial. Next slide, please. Here I've used one of the files which is available in ECMWF repository, this data repository specifically, and this is the mean sea level pressure field. The colors are not really up to a level what we get in Magix, but it's still a good way to present. And at least we can see some things with Matplotlib. Next slide. This is the precipitation field. Again with Matplotlib, which we have in Magix tutorial, but in a much better way. Next slide. Again, now I've used some data to plot the contours, and which provides us the terrain over the world map. And this is again similar to what we get in Magix. Next slide. Now I've tried to get, so this is similar to the previous plot, but here I've tried to provide a shading to that. This is possible. All of these things are possible with this base map and Cartopy API, like these libraries, which are currently being developed in Python. But again, this is still in development and not as far as with what we get with Magix. Next slide, please. This is for the temperature shading. And again, this is quite similar to what we get in Magix. So it's this one is a good plot. Next slide, please. This is one of the things that I mentioned before as well. So when we are using Magix, we get this, you can just mention Eastern Europe or Central Europe and you get this direct plot. But when I'm plotting it in Matplotlib, I have to specify the coordinates of for this latitude and longitude. And even with that, once we get that, and then we can have something like this river network across Europe. So this is also possible. So what I'm trying to show here is that many of the plots can also be plotted with Matplotlib, which are mainly done with Magix, but still it's in early stages. We don't have this very user-friendly and good-looking outputs as we get with Magix. Next slide. This is again a Lambert projection, which we can get as well. Next slide. This is again now a cylindrical projection for Australia from in Matplotlib. Next slide, please. Okay, so as I'm discussing this for now with Magix and Matplotlib, this is the next the way forward. Matplotlib offers plotting functionality with basemap and Cartopy packages for geographical plotting, but as we have seen, Magix is still much superior for geographical plotting. But since the model training API is in development for CliMetLab, Matplotlib will be highly effective when we are going for this curves we get with ML models. So that's the next step. Next slide, please. All right, so these were the mainly two tasks that I worked on. And there is another task that was supposed to be experimental, and we wanted to see if we can work on it. And this was just supposed to be exploratory work. And in this work, what we wanted to see is mainly if we can try to see how we can store this large data sets and how we can process them. So for small scale data sets, the conversion between different formats is simple, and there are many other APIs are available for that. But as I've shown here, so if you have an HCDF format data set, we can convert it into ZAR format simply with X-ray, and similarly for grid. But when we want to process large-scale data sets, it's not this simple. I mean, it can be done, but it's very a long process. If you try to go for data set which is say in GBs or in TBs, so it could take very, very long. And that's why we need some simple way to process that. And we've also, this is a much later work. I mean, this is not in plan for the next few months at least. This could be, once the CliMetLab is much mature, we can add this functionality of having processing this parallelly and adding this X-ray things. But as I mentioned, this is experimental thing. So next slide, please. Why we have this concerns of data storage. So we want to have multi-threaded parallel read and write. We want to avoid swapping in chunking strategies. So when the data is, as I mentioned, in large size, we want to have chunks of the data so that we can have the data stored properly as well as access, faster access. So for that, we need to have good chunking strategies. Then we also want compression and CPU time required to uncompress or compress. We need to work on that as well. We need to have faster access to data. And we also want to check the performance on cloud storage, how it goes. So for all these, we need Zara-like alternatives, which can help in efficient storage and handling with the help with Accelerate. So this is still like some experimental things. Next slide. Okay, so as part of this ESoC, I mainly worked on first two tasks. And currently I'm just starting with the third task, which would be, I'll be continuing since the package is much more in development. And I'll be trying with multiple data sets and CPU clusters to see which strategies work better. Next step would be, once we have enough development, we can merge the Matplotlib driver development into main CliMetLab package. So as I mentioned, user can have these two packages that they can use for plotting. And we are also planning for further development and feature addition in CliMetLab package, like more drivers if needed, then caching mechanism for the data specific to machine learning projects, and a few more machine learning specific features. So these are the next steps that we have planned. Next slide. Okay, yes. So that's it from my side. This was a really great working with Florian and Bodon. I learned a lot. I mean, this was, and it's fun to work in such a initial stage package. So I'll encourage people to join and contribute to this package so that we can move it forward. And yes, thank you for your time.
Thank you, Ashwin, for presenting your great work and your enhancements to CliMetLab. And thank you for your presentation now. So I have a question regarding, will you continue also being involved in the developments of CliMetLab?
Yes. So as I mentioned, it's still in very much early, like it's in early development stage. So I'll be happy to continue my contribution to it. And as I mentioned, I want to merge this driver code that I've added. So I'll be working with my mentors for that.
Okay, great. So yeah, with this, I thank you again for being part of ECMWF Summer of Better Code this year. It was a pleasure to have you. And thank you again for your time today.